Moving on to example number 3. All right, so this is the one I was talking about, where we have a sum or difference now occurring between two rational expressions on one side, the left side in this case, of the equal sign. So we cannot cross multiply here. Instead, what we're going to do is multiply both sides by the LCD. We should understand that this is a difference of two squares occurring in this denominator, and the factorization of that x minus 1 is equal to this product. So knowing that allows us to determine what? It allows us to determine that the LCD is in fact the product of the quantity x plus 1 and the quantity of x minus 1. So what we're going to do is multiply both sides of this equation by that LCD. X plus 1, x minus 1. All right, so on the left-hand side, let's begin the distributive process. So x plus 1, x minus 1 times 1 over x minus 1. Note, you have an x minus 1 over another x minus 1. So in this first wave of the distributive property, the x minus 1s are going to be eliminated. And you just get x plus 1 times 1, which is x plus 1. All right, it's really 1 times x plus 1, but it is, of course, x plus 1. Anyway, moving on to the second rational expression, right here. You have a 4 on top, and then what's being canceled out? Do you see? You have an x plus 1 over another x plus 1. So you're left with just x minus 1. So it's 4 times x minus 1. Now on the right-hand side, notice, again, this is equal to the LCD, so they are both eliminated, and you're left with just a 7. All right? LCD divided by the LCD, of course, just gives you 1. So 1 times 7 is 7. All right, let's distribute. Here we get what we thought, x plus 1. Now distribute the 4 through. So that would be 4x minus 4 equals 7. And then rock and roll. Go to work. X plus 4x is 5x. 1 minus 4 is minus 3. That's still equal to 7. Then you're going to add 3 to both sides. And that's going to give you 5x equaling 10. And finally, you're going to divide both sides by 5, leaving you with the correct answer, x equals 2. Now you want to check. Make sure that when you plug in a 2 into the x's in the original equation, specifically into the denominators, you do not get 0. And so we're fine here. So x equaling 2 is the solution because it does not make any one of these denominators 0. If it did perhaps, then it would not be a solution. For example, what if we got x equals 1? Well, if you were to plug in a 1 here, 1 minus 1 is 0. That would lead us to an undefined situation. So therefore, if you did hypothetically end up with x equaling 1, 1 would not be a solution here. Okay? It would be considered an extraneous solution. All right, moving on to example number 4. Ooh, radical involved in this one. Okay, so let's see what we can do to this thing algebraically to ultimately solve for x. How would we get rid of this square root symbol? How would we get rid of this radical? Well, we could get rid of it by squaring both sides. And if we square both sides, what's going to happen? On the left, when you square a square root, it disappears. And you're left with whatever is underneath that radical. In this case, x squared minus 1. On the right-hand side, be careful. We looked at this situation before. Be careful. This means what? This means x plus 1 times x plus 1. In other words, what does it mean? Foil it. It means this. X squared plus 2x plus 1. So let's go ahead and write that down. X squared plus 2x plus 1. All right, now, let's see if we can figure this thing out. So let's add x to both sides. And let's also add a 1 to both sides. And so what do we get? We get 0 is equal to what? X squared plus 3x plus 2. Ooh, I threw a curveball at you. Ooh, I guess I misspoke earlier. We are ending up with an equation now ultimately that's not linear. This is quadratic. But this is a very basic one, so I think we can handle it. Okay, and ultimately, it's in this section because the factorization of this, it consists of linear factors. So let's see what we can do here. Do we remember how to solve something like this? Well, let's factor this quadratic expression. Let's factor it. We should know how to do that. Xx, and then this is prime, so that's got to be a 2, that's got to be a 1. And then we're looking for a 3x in the middle. So this has got to be positive, this has got to be positive. Right? Because 1x plus 2x equals 3x. Okay. So does it make sense that if you have something like this, in other words, if you had something like this, if you had 0 is equal to a times b, okay? Would this be true if a is equal to 0? If a is 0, 0 times anything is 0, right? Yeah. Would it also work if b is 0? Yeah, if b is 0, 0 times a, anything, is going to give us a result of 0. So this is actually called the zero product property that we're looking at right now. So we can use that now with respect to this situation because we understand that if this entire thing, if this entire factor is equal to 0, okay, or this entire factor, if it's equal to 0, then the whole thing, the whole product is equal to 0, right? So all we have to do is solve these two linear equations, all right? That's why it's in this section. So we have x equals -2, or we have x equals -1. And so we just put a box around that and we move on with our lives, right? They're both correct, obviously, right? No. Remember, this was not a simple linear equation to begin with. You could be ending up with extraneous solutions, so you'd better be checking your work. So let's go ahead and do that. Let's go ahead and check -2. So let's put a -2 in here. All right, first, so the opposite of -2 is what? 2. The opposite of -2 is 2. 2 minus 1 is 1, and the square root of 1 is 1. Okay, so we get 1 on the left when we replace this x with a -2. What happens on the right, though? You replace this x with a -2, you get a -2 plus 1, which is -1. Does 1 equal -1? No. 1 does not equal -1. Therefore, -2 is an extraneous solution. It will not work. Make sure this one works. So what's the opposite of -1? 1. What's 1 minus 1? 0. What's the square root of 0? 0. Yeah. On the right-hand side, replace this x with a -1. What's -1 plus 1? Oh, it's 0. Does 0 equal 0? It sure does. So the only answer, the only solution in this particular equation is x equal to -1. All right, the last thing we have to look at here in section 1.6 is solving for a specified variable. So this is just the formula for converting from degrees Celsius to degrees Fahrenheit, in case you remember that from maybe your chemistry class or something. What we're asked to do here is solve this equation for C. We want to have C equal to something. We're solving for this variable right there, all right? So all we have to do is just undo everything around this expression as it relates to C and get C by itself. So what we're going to do is we're going to subtract 32 from both sides first. That's going to give us F minus 32 is equal to 9/5 C. And now we got to get rid of the coefficient in front of C. We got to get rid of the 9/5. And how do we get rid of this fraction? Well, you get rid of it by multiplying it by its reciprocal, right? So we're going to multiply both sides of this equation by 5/9. On the right, everything cancels except for C. And you could leave it just like that. So what am I saying? C equals then, therefore, 5/9 times the quantity of F minus 32. I will tell you in WebAssign, make sure you watch your lowercase versus your uppercase. If you're given something like this and you're solving for uppercase C, and the answer contains an uppercase F, make sure you leave it as uppercase F, not lowercase. So what I'm telling you then is WebAssign is case sensitive. So be careful. In general, you're going to use lowercase. In general, in WebAssign, you just use lowercase letters for your variables, like X would be lowercase, for example. All right, let's do the last example, okay? Of course, this is the perimeter formula. We're going to solve this thing for W. Okay, so I'm going to subtract 2L from both sides. That's going to give me P minus 2L is equal to 2W. And now the last thing I need to do is multiply everything by 1/2, right? Which is the same as dividing both sides by 2. Okay? What we end up with then is the width is going to be equal to 1/2 times the quantity of P minus 2L. You can leave it just like this. This is fine. This is fine. Stop here if you like. This is fine. If you really want to, though, you can distribute the 1/2 through, and that would give you this. Either way, okay? Either way. All right? Okay, so that completes the notes here for section 1.6. Again, if you have any questions or concerns, please do not hesitate to email me with those, and I'll do my very best to assist you. Hope you're well. Hope you're still trying to enjoy the college campus life, and you're hanging in there, and I'll see you at our next Zoom meeting. Take care.